Good morning all. This is Satish Kumar, Assistant Professor of EC Department. Now let us see the another video lecture series on linear convolution in discrete Fourier transform. Now we can see the empathy, convolution in real life, audio echo and reverb systems, image blurring and sharpening, and filtering noise in digital communication. The mind map nodes of convolution are input X of n, output Y of n, impulse response H of n. The initial signal enters the system and then visual representation of the system component is created, and finally the system response to be input is determined. The process signal emerge from the system. Next one, define input signal X of n, the signal entering the system, and then our unit sample response H of n, the system response to a single impulse, and then output Y of n, the system response to the input. The linear convolution relates the input and output and unit sample response of the DT systems. Linear convolution is a very powerful technique used for analysis of linear time invariant systems. Y of n is equal to X of n into H of n. Next one, the behavior of the LTE system is completely characterized by the unit sample response H of n. Y of n is equal to summation k is equal to minus infinite to plus infinite x of k into H of n minus k. It is the linear convolution of X of n, and H of n gives output Y of n. Therefore, X of n can be applied to LTI DT system, which can produce us the output as Y of n. This is the representation of convolution, input sequence X of n, and also input sequence 1 X1 of n. We can get the convoluted sequence. For the input sequence X of n and input sequence X1 of n, going to compute these two sequences, we can get the convoluted sequence of the system. Next one, define methods of linear convolution. There are four methods available to compute linear convolution: definition method, graphical method, tabulation method, and multiplication method. Definition method is the direct application of the convolution. Graphical method is the visual representation of the convolution. Tabulation is the tuple based approach for computation. Multiplication utilizing multiplication in frequency domain. Next one, steps to find the linear convolution. Let capital M be the total number of samples of X of n and capital N be the total number of samples of H of n. Then the total number of samples of Y of n will be M plus N minus 1. Four steps involved in computing convolution sum, that is nothing but linear convolution: folding, shifting, multiplication, and summation. Next one, by using previous four steps, we can going to find the linear convolution, that is nothing but input sequence can be already given, impulse sequence can be given. By applying folding, shifting, multiplication, and summation, we can get the linear convolution. Y of 0 is equal to 1, y of 1 is equal to 2, y of 2 is equal to 4, y of 3 is equal to 6, y of 4 is equal to 6, y of 5 is equal to 7, 6 is equal to 5, y of 7 is equal to 4, y of 8 is equal to 2. This is the input sequence and impulse response sequence. We can get the convoluted sequence as linear convolution. Next one, another example, by using tabulation method, we can get the samples as 1, 2, 3, 4, 5, 6. X of n, H1 of n is 1, 2, 3, 4, 5, 6. We can get by using tabulation method, multiplying and then summing, we can get the answer as Y of n is equal to 1, 4, 10, 20, 35, 56, 70, 76, 73, 60, 36. This is the linear convolution tabulation method. Next one, properties of linear convolution. It can be classified into three properties: commutative property, associative property, and distributive property. Commutative property can be defined as Y of n is equal to X of n into H of n, H of n into X of n. When we are applying the X of n, we can get the output as Y of n. When we apply the input as H of n, which can produce the output as Y of n. Next one, associative property: x of n multiplied with h1 of n again multiplied with h2 of n, we can get x of n into h1 of n into h2 of n. X of n multiplied with h1 of n again multiplied with h2 of n, which can produce output as y of n. Right hand side sequence: x of n multiplied with h1 of n again multiplied with h1 of n, we can get it as output as y of n. Right hand side is sequence x of n multiplied with h1 of n into h2 of n, which can produce the output as y of n. Next one, distributive property, x of n multiplied with h1 of n plus x of n multiplied with h2 of n, which is equal to x of n into h1 of n plus h2 of n. X of n multiplied with h1 of n multiplied with h2 of n. Going to add these two sequence, we can get the output as y of n. Right hand side sequence, x of n multiplied with h1 of n plus h2 of n, which can produce the output as y of n. Next one, this is the input output transference x of n that can be applied with h of n, which can produce the output as y of n. By using inverse linear change or something inverse, we can get x dash of n that can be applied to h of n, which can produce the output as y dash of n. This is the prototype of real-time simulation, graph of x of n and flipped as h of minus k. By using MATLAB demo suggestions, FIR filter as convolution engine, input signal can be applied to convolution block, which can produce the output as sum, that is nothing but linear convolution. Audio signal filtering example, that can be connection to DSP hardware. These are the steps: summing points, flipped impulse response, input signal, convolution block and output signal. Next one, this is the mind map, reflection and innovation. First, we can going to compute the y of n is equal to x of n into h of n for the given sequence. Identify the type of system, that is causal or non-causal. Real-time signal processing in IoT devices, such as nothing but audio enhancement techniques for improving the digital audio quality. AI applications role in convolution neural networks and the output length of the resulting output sequence. Next, we can see the assessment. Define linear convolution. Y of n is equal to summation k is equal to minus infinite to plus infinite x of n into h of n minus k. Total number of samples in y of n will be m plus n minus 1. M be the total number of samples of x of n be the total number of samples of h of n. Then the total number of samples in y of n will be m plus n minus 1. List the methods involved to compute convolution sum. There are 4 methods available to compute linear convolution, that is nothing but definition method, graphical method, tabulation method, multiplication method. Y of n is equal to x of n into h of n. H of n into x of n is defined as commutative property. Mention the steps involved to compute linear convolution. There are 4 steps involved to compute linear convolution: folding, shifting, multiplication, summation. List the properties of convolution sum. That is nothing but commutative property, associative property and distributive property. Thank you.